In this example, we will be doing an application problem that will be involving solving systems of linear equations. And this one in particular is about distance, rate, and time problems. Let's read the problem. A plane flies with the wind 252 miles in 1 hour, 24 minutes. On the way back, the plane flies against the wind, so the return trip takes about 1 hour, 48 minutes. What is his speed in still air, and how fast is the wind blowing? Alright, again, just like all my other problems, I'm going to start by defining variables. So what don't I know? I don't know the speed of the plane in still air. I also don't know how fast the wind is blowing, so speed of the wind. Now that I have my variables, I can start writing equations. For distance, rate, and time problems, I really like to set up charts for distance equals rate times time. Before I do that, I'm actually going to look at this time. Okay, so time is in hours and minutes. I don't really want 2 units there, so I want to put it in just hours, because in general we'll talk about miles per hour. So how do I change those 24 minutes into hours? So it's 1 hour and so much time. So I'm going to start with that 24 minutes. And I need to convert it to hours. I know that there are 60 minutes in 1 hour. So I put my 60 minutes in the denominator so that my minutes divide out. And that equals 1 hour. Now I have 24 divided by 60. The minutes divided out, those units are gone, and I only have hours. And since this divides out nicely, 24 divided by 60 is 4/10. I'm just going to leave it as 4/10 of an hour. So I have 1 hour already plus 4/10 of an hour. So this part of the trip took 1.4 hours. I did the same thing with my other. So 1 hour, 48 minutes. I want to convert that 48 minutes. 60 minutes is in 1 hour. So I end up just dividing 48 by 60 to get the hours, and that is 0.8 hours. So 8/10 of an hour. So overall, that part of the trip took 1.8 hours. Alright, now that I've converted that, I can go ahead and move on to my chart. So I have a trip with the wind. I have a trip against the wind. And I know distance equals rate times time. And then I start to fill in my boxes. So, distance. I know that I'm flying 252 miles, and I'm taking the same return trip. So with the wind, against the wind, I'm traveling 252 miles. I'm going to fill in that box. I'm going to come back to rate. I know that when I was traveling with the wind, that was the 1 hour, 24 minutes. So 1.4 hours with the wind. And then on the way back, we're flying against the wind. That was the 1 hour, 48 minutes, or 1.8 hours. And now I need to think about the rate. So we don't just have one variable here. We have 2 things going on. We have the rate that the plane is traveling, and we also have the wind. The wind is going to help us or hurt us. It's going to make us go faster or slower. So if I'm flying along and the wind is blowing me, I'm going to move faster. So my overall rate will be faster. So if I have the speed of the plane plus the speed of the wind is going to make me move that much faster overall. When I'm flying against the wind, I have the speed of the plane that I'm traveling, but the wind is slowing me down. So if I'm traveling and then the wind is blowing at me, I'm going to start going slower. It's going to slow me down by that much. So my rate stays constant, but the wind can either push me along or slow me down. Alright, now that I have this filled in, I know distance equals rate times time. So that's how I form my two equations. 252 will equal, I'm going to go ahead and write this out front because it's more aesthetically pleasing to my eye, 1.4 times that whole quantity, P plus W. So this whole thing here is the rate, and it's going to be rate times time. And I can multiply in any order I want, I just flip-flop the order there. Same thing with my trip against the wind. Distance equals my rate, which is here, times time. I'm just writing the time first. And there you go. I have two equations and two unknowns. From here, I can do a couple things. I could distribute, but then I've got these decimals that I have to deal with, 1.4 and 1.8. They're not amazing decimals. Or I could try to divide both sides by that and get the variables alone. So what do I mean by that? I mean divide this side, so divide it by 1.4, and divide the other side of the equation, divide this side of the equation by 1.4. Whatever I do to one side, do the same thing to the other side. And that would make me end up over here. So 252 divided by 1.4 is 180. And then this side it would divide out, and I'd be left with just P plus W. Right? If I'm multiplying by 1.4, dividing by 1.4, it's divided out, it's gone. I would do the same thing over here. Divide both sides by 1.8. And 252 divided by 1.8 is 140. And this side is divided out, and I'm only left with P minus W. So once I divide out that value, I actually have something really nice that's set up for elimination. I already have a plus W and a minus W that is 0. So I have eliminated the variable W. I look at what's left. 180 plus 140 is 320. And a common mistake I see is students just want to write P, but it's 1P plus 1P is now 2P. Divide both sides by 2. The speed of the plane is 160. The units on that, because we were talking about hours and miles, would be miles per hour. That's only half my answer. I needed to know the speed of the plane and the speed of the wind. So I can use any of these equations here. I could go back to my original equations, but I just divided both sides by 1.4 to make it prettier, to make it nicer to deal with. So I could actually just use this equation. This is equivalent to that one. They're the same equations, I just divided out 1.4 to both sides, so it's still equal. So I'm going to use this equation to find my wind. So I have 180 equaling P, I'm going to replace with 160 plus W, subtract 160 from both sides, and that means that the wind would be 20 miles per hour. Sorry, I ran out of room here. And there you go, we have the two answers. I hope that helps.